Guys, so I'm going to walk through this example in your notes with you. You're going to see this in the homework, so I just want to make sure that you have an example to reference when you're working at home. So the question says factor p of x, which just means factor this function, factor p of x into linear factors given that k is a 0 of p. So first let's backtrack to this idea of the remainder theorem. The remainder theorem says that if k is a 0, then when I divide, either using synthetic division or long division, I'm going to get a remainder of 0. That's what the remainder theorem says, that if k is a 0, or a solution, a root, an x-intercept, all of those mean the same thing. If k is a 0, then when I divide, I'm going to get a remainder of 0. So I'm going to take this k equals -3. Now they already told me that that was a solution, so I'm going to use that with synthetic division to divide into p of x. Now notice the sign of -3 from the k and in the box is the same. Because they already told me k, they didn't give me in the form of a factor. They told me that k was -3, that would be the factored form. Because they told me that k is -3, when I put it into the box for synthetic division, it's not going to change signs. It only changes signs when it's in that x plus or minus a number form, when it's in the factored form with the parentheses. So I'm going to write my coefficients across the top, and then I'm going to start my synthetic division. So I'm going to multiply, carry down my first one. Now I'm going to multiply -3 times -1, which is going to give me -3, and then I'm going to add right here. So 1 plus -3 is going to give me -2. I'm going to multiply again. -3 times -2 is going to give me +6, and then I'm going to add and have -15. Multiply -3 times -15, which is going to give me +45, and then I'm going to add and get a 0. If they tell you in the instructions that k is a 0, this remainder better be 0. If not, you've done something wrong in your synthetic division. So since the remainder equals 0, k equals -3 is a 0, or a solution of the function p of x. That's what the remainder theorem says, which I knew that going in, but that's good that I actually got out 0, so I did my math probably correctly. Now I'm going to take this thing, write it back in its function form. So if you remember from synthetic division, when you write out your quotient or your answer, you are going to take 1 degree less than you started with in the original function. So I'm going to have a 2 here, and then that's going to become my coefficient for the next, and then so on. So there's my answer, my quotient that came out of that synthetic division. Alright, so now from here, because I am finding, let's go back to my question, the factored form, I don't know how to factor this thing. Now, yes, you could check factor by grouping because it's 4 terms. They will sometimes factor by grouping, but more times than not, they will not be factorable by grouping. That's why we have kind of this next step. Synthetic division will always work, assuming that you have at least 1 0 given. So now I'm going to take this thing, and I need to solve it by either factoring, which is always my first choice because it's easiest. Not everything will factor though, so if it's not solved, if you can't factor it, then you're going to have to go to the quadratic formula, which if you remember from the last chapter, quadratic formula will always work. So this one does factor. It's going to give me x minus 5 and x plus 3 because I'm looking for two numbers that multiply to -15. Well, -5 times +3 gives me -15, and I want them to add to -2. -5 plus 3 indeed gives me -2. So this one just asked for the factored form. Now this thing is already factored right here. There's no need to solve it because the directions did not say to write the zeros of the polynomial or to write the solutions or to solve the polynomial. It just said to factor. So it's already factored. Now remember, I have that factor that's given. So this one way up here that was given in the question, I need to carry that thing down. So I have an x plus 3, and then I have those other two that I just found, x minus 5, x plus 3. So those came from right there. Now, I don't need to write x plus 3 times x plus 3, so I'm actually going to be able to condense this thing down and write it as x plus 3 squared. And that is the factored form of p of x. Now, order doesn't matter. If you were to write it as x plus 3 squared times x minus 5, either one of those would be correct, just as long as you have all of the factors in there. Just to tie into what we had from last class, from 4.1, a degree of 3 means that you're going to have 3 solutions. Well, here's my 3 solutions. 1, 2, 3. So all 3 of those give me the 3 solutions. Now, yes, I have the same answer twice. We're going to talk about that in the later sections, but a degree of 3 should give you 3 factors. Now, in our case, 2 of them were the same, so I was able to condense them down.